happy spring break. Here we are working on trig, and this is the first of several videos that I have for you. This particular video is on section 5.2, where we formally begin our study of trig. We learned about angles in 5.1. So the trig functions are really a ratio of the sides of triangles. And we're always going to begin our study here with a triangle that has an angle coming from the initial side to a terminal side. And there is some point P which can be called xy, of course, as any coordinate. Well, once you've labeled that point xy, you'll know already that the length is x and the height here is going to be y. From that, we will then get our 6 trig functions. The sine of theta, theta being the angle, is a ratio which compares y over r. In other words, the height in red compared to the hypotenuse r. We abbreviate it as the sine of theta is equal to y over r. The next trig function is the cosine of theta. The cosine of theta is the ratio of the side of the triangle x as to r, the hypotenuse. And again, the abbreviation is there for you. The next one, tangent of theta, is comparing the two legs of the triangle, and it would be y over x. The cotangent, please notice, is the reciprocal of the tangent. Where tangent was the comparison of y over x, the cotangent is the ratio of x over y. Similarly, we have the secant of theta, which is r over x, which happens to be the reciprocal of the sine function. And lastly, we have the cosecant, and the cosecant is the reciprocal of the sine function, and it is r over y. Well, in our study, we have to remember the Pythagorean theorem. And the Pythagorean theorem, of course, is, well, we always use a, but in this case, we're going to use x. X squared plus y squared is equal to r squared. And once, of course, we solve for r, we have r is equal to the square root of x squared plus y squared. Now, in this case, we officially, technically, need to take the positive and the negative whenever we take the square root. However, we know a length of a triangle has to always be positive. Further looking at these signs, or trig functions, I want you to begin thinking about them as sides of the triangle. Compared to an angle theta, we're going to be talking about the side which is opposite the angle and the side which is adjacent to the angle. And of course, in any right triangle, you always have a hypotenuse, which is the longest side. Well, this ties in directly to the last page where we had our axes. Now this is my angle, and of course we're going to learn this is a reference angle. But we still have our side, our height here as being y, and our adjacent side from the angle as being x. Well, that lends itself to the same thing we just learned, because now the side opposite of y over r, just what we did on the previous page. The cosine is x over r. The tangent is y over x. The nice thing is that, again, they are reciprocal functions, And I've set the reciprocal functions next to each other. This is how I keep them memorized. The cosecant is the reciprocal of sine, and of course my reciprocal then would be r over y. The reciprocal function of the cosine is the secant, and again that would be r over x, and the reciprocal function of the tangent is the cotangent, and it would be x over y. Now, I'm sure that all of you have probably heard, if you've ever heard of trig or began studying trig in the past, you've heard of something called SOHCAHTOA. And SOHCAHTOA is an acronym to help you remember how to make sure you get these 6 trig functions correct. And to be honest, I can never remember how to spell SOHCAHTOA, so it doesn't do a whole lot for me. But I will show you what it says. It says the sine is the opposite over the hypotenuse, so the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. SOHCAHTOA. I couldn't remember to spell that for anything. So years and years ago, I had someone tell me that to remember it as Oscar had, let me put it in the order, that way it will help. Oscar had a heap of apples. And I can spell Oscar had a heap of apples. And the nice thing is you'll see it's all of those opposite, hypotenuse, opposite, adjacent. And they go right in the same order as we teach them. So it's the sine of theta, the cosine of theta, and the tangent of theta. So I just set mine up as the sine, cosine, tangent, and then I go right down. Oscar had a heap of apples. You have to know those or those 3. You have to memorize them. Find a way. If you like SOHCAHTOA, that's fine. If you like Oscar had a heap of apples, that's fine. Because then once you have those 3, it's easy then to find the reciprocals, which the cosecant is the reciprocal, which will be h over a. And of course, the secant of theta will be the reciprocal of the cosine, which is um, I said h over a, h over o, and I wrote it correctly. I apologize for that. The hypotenuse over the adjacent, and the cotangent, of course, the reciprocal function of tangent would be the adjacent over the opposite. Once you have those 3 memorized, however way you want to memorize them, SOHCAHTOA or Oscar had a heap of apples, the reciprocal functions think and fall right into line. So we're going to be given an angle here, an angle from the initial side with the terminal side going through the point 12, 5. We know that 12 is my x and y is my 5. The first thing I need to do is find r. R is my hypotenuse, so we know r is going to be equal to the square root of x squared plus y squared. So using that formula, r will be the square root of 12 squared plus 5 squared. R therefore is the square root of 144 plus 25. R then is the square root of 169, and R then is 13. So now I found R to be 13. Once I have all of the lengths of that triangle, then I can find all 6 trig functions. So again, I like to do the Oscar had a peep of apples. So we're going to do sine of theta, cosine of theta, tangent of theta. Here we go. Oscar had a, and I just wrote it wrong. Oscar had a heap of apples, or if you prefer again, SOHCAHTOA. In the same reign, we should also keep in mind that the sine is y over r, the cosine is x over r, and the tangent is y over x. I'd like you right off the start to be thinking of those together or as the same, be looking at every triangle that way. So y is 5, r is 13. The cosine of the angle, therefore, is x, which is 12, over the hypotenuse, r, which is 13. And the tangent, of course, is the side opposite over the adjacent. And that, of course, would be 5 over 12. Keep in mind when I'm saying opposite and adjacent, if I'm coming from the angle theta, the side opposite is directly across the side adjacent. Adjacent means next to. R, my hypotenuse, is always the longest side of your right triangle. So now let's go back and get the reciprocal functions. Let me move this so I have a little bit of room. So r is equal to 13. So now we're going to have our reciprocal functions. And again, our reciprocal functions, we have the sine, which is going to be the cosecant of theta. The cosine is the secant theta, and the tangent is the cotangent. So we're just going to take the reciprocal, 13 over 5, 13 over 12, and of course 12 over 5. Here's another example. This particular example, I put that on there because theta is a very large obtuse angle. So we need to take a look at what happens when we have an obtuse angle like this. We're going to look still at xy, my x being 8, negative 6 being my y. So let's put that on there. This is my x, this is my y, but I do need to find r, don't I? So r is equal to the square root of 8 squared plus negative 6 squared. R would then be equal to the square root of 64 plus 36. R, of course, is equal to the square root of 100, which, of course, is simply 10. Again, we're going to find all 6 of our trig functions. So the sine of theta, the cosine of theta, and the tangent of theta. Again, I want you to think of them as the side opposite over the hypotenuse, the side adjacent over the hypotenuse, and the side opposite over the adjacent. And when I'm looking at this particular triangle, of course, that's y over r, x over r, and y over x. Again, make those connections. So looking at ours, we have y, which is going to be negative 6 over r. R is 10. We need to reduce that. Reducing that, we get negative 3/5. For the cosine, it is x. X is 8 over r, which is 10. Again, reducing that will be positive 4/5. The tangent, y, negative 6 over x, 8. Reducing that, of course, would be negative 3/4. From that, we can get our reciprocals, and I'm sorry, I'm going to have to kind of squeeze this in here. We have the cosecant of theta, which will be negative 5/3, the secant of theta, which is going to be 5 over 4, again reciprocals, and the cotangent of theta, which is going to be negative 4/3. It's important to recognize here that the trig functions are the same no matter which point is used to find them on the terminal side of the angle. Had I picked a point here that's closer on same line, in other words, my ratios are going to remain the same. It could have been that y is negative 3 and x is 4, and then r would have been 5. Since it's all ratios, any point on that terminal side will give me all the same trig functions. So here's a problem here that says find the values of the 6 trigonometric functions of angle theta in standard position. If the terminal side of theta is defined by 3x minus 2y is equal to 0, and we're saying in this case x is less than or equal to 0. And the reason we're putting that interval there on x is so that we know which line and which angle to know which one to use, because as you know, a line that's graphed, and this happens to be the line 3x minus 2y, a line would go on in every direction. But by putting that interval on, we know we want this line here, and I'm going to erase that writing, but I just wanted to show that y is there. So since it is less than 0, the graph of that line is shown there on the left. In other words, this is a line through the origin with a slope of 3/2. Then we're going to find a point on the line. One of the points on the line is in fact negative 2, negative 3. So let's go find that point, negative 2, negative 3. Once I found that point, now I can go ahead and find all 6 trig functions. So I'm going to get a line here. So I have theta, my terminal side, my point here being that x is negative 2, means this side is negative 2, my y being negative 3. So I have two sides of my triangle. I need to go and get the hypotenuse, and of course we know the hypotenuse r is equal to the square root of negative 3 squared plus negative 2 squared. So r is going to be equal to the square root of 9 plus 4, which means r is the square root of 13. And again, we didn't have to take the positive or negative simply because we know the length has got to be, the radius has to be a positive. Now that I know that the hypotenuse is in fact the square root of 13, I can go ahead and find my 6 trig functions. So I'll start, of course, with sine, cosine, and tangent. We know that the sine is y over r, x over r, and y over x, which of course is the side opposite over the hypotenuse, the side adjacent over the hypotenuse, and the side opposite over the adjacent. Again, think of them both ways. So if I look at this, my sine would be negative 3 over the square root of 13. Well, we know from previous study that I can never leave a radical in my denominator, so I need to rationalize that denominator. To do that, I'll multiply by the square root of 13, and I'll get negative 3 square root 13 all divided by 13. And that's going to be my sine of the theta. Next, let's work on cosine of theta. Cosine of theta is x, or the adjacent side, over the hypotenuse, or r. So that's going to be negative 2 over the square root of 13. Much like before, I can't leave a radical in my denominator, so I must rationalize my denominator by multiplying by the square root of 13. I'll end up with negative 2 square root 13 all divided by 13. Next, working on my tangent. My tangent is the side opposite over the adjacent, or y over x, which would be negative 3 over negative 2, which of course is simply 3 halves. Okay, let me see if I can move this. Didn't want to get it all, did it? Try to move this out of my way a little bit so I can get my reciprocal functions. Give myself a little room. Great. So my reciprocal functions can then be written. And of course it is the cosecant of theta. Now, I want to go back and do the least amount of work that I possibly can. So when I look at the cosecant and the sine, and I know I want the reciprocal, I'm going to go right back to where I originally had it, because then I'm going to have the square root of 13 over negative 3, which is of course negative square root 13 over 3, and I don't have a radical in my denominator. Likewise, when I go to secant of theta, I'm going to go back and look my original ratio there, which was negative 2 over the square root of 13. When I take the reciprocal, I'm going to have negative square root 13 over 2. Again, my radical has been resolved. And lastly, the cotangent, which is the reciprocal function of the tangent, would then be 2 over 3. Next, I want to look at one of what we're going to be calling, or I already defined it as a quadrantal angle, and making sure that we begin looking at what's going to happen at quadrantal angles. Let's look at those six trig functions. So I have the sine of theta, cosine theta, tangent theta. Again, here my point is x is 0, y is negative 5. When I have that special quadrantal angle, you have to remember x, y. So in this case, it's quite special because x is 0, y is negative 5, but r is also going to be 5. It is the length of the radius at that point. So r will also be 5. Knowing that, then I can go ahead and get my 6 trig functions. Again, um, the sine is y over r, cosine x over r, and tangent y over x. The tangent then would be negative 5 over 1. The cosine then would be 0 over 1. And of course, here we'd have negative 5, of course, divided by 0. So of course, we need to clean these up. Negative 5, 0, and undefined. Yes, That's the problem in our quadrantal angles. When you're having an x or a y being 0, you'll have in the tangent and or the cotangent, you'll have division by 0. And of course, division by 0 is undefined. Let's get those reciprocal functions. Cosecant theta then would be negative 1/5. The secant of theta then would be a problem, wouldn't it? Because I'd have 1 divided by 0, which we know is undefined. And the cotangent here would be the reciprocal function, 0 divided by negative 5, which of course would be 0. So we have to be real careful about our quadrantal angles. So let's just see what happens here. Whenever we have our zeros, you have to watch out for your division. So I just pasted in a chart about the 6 trig functions of the quadrantal angles. Notice that at 0, I would have undefined for cotangent and cosecant, while 90 degrees is tangent and secant, and so forth. You have to keep those in mind, and you can always figure them out by simply getting your x, your y, and your radius. So given those values of quadrantal angles, you may be given something like this, and it says find the value of the tangent of 360 degrees plus 4 times the sine of 180 degrees plus 5 times cosine squared of 180 degrees. That means take the value of the cosine of 180 and square it. So I'm going to know that the tangent at 360 degrees, which really is the same as 0 degrees, the tangent there is 0, plus 4 times the sine of 180. 180, the sine of 180 is in fact 0, plus 5 times the cosine of 180 squared, and the cosine of 180 is negative 1, and I'm going to square that. Of course, some quick mathematics shows us that negative 1 squared is positive 1 times 5 is 5, and everything else is 0, so my answer is simply 5. Next, we want to take a look at the reciprocal functions, which we've already talked to you about, and I've been saying that the cosine, sine, and tangent each have reciprocals, and to know what those are, making sure of that, I want you to make sure of how to use your calculator. Right here, I do not have a TI-83 or 84 calculator simulator software like I would have in class. However, I'm just going to write out what you have to be careful about so you know. If you were asked for the cosecant of some value, let's just say 45 degrees, on your calculator, the only trig functions you have are sine, cosine, tangent. If you want the cosecant of 45 degrees, you know that the cosecant is the reciprocal function of the sine. So the way I'm going to enter it in my calculator is I'm going to put 1 divided by the sine of 45 degrees, because it is a reciprocal function. The other thing that you could do is take parentheses, sine 45 degrees, and then use your negative 1 key, meaning it's going to be dropped to the bottom. What you need to be careful about is that this negative 1 is an entirely different key and function than on your calculator when you go to the second function and you say sine to the negative 1. You cannot use this button to find the cosecant. That means the inverse sign. Two totally different things in your calculator. So be very careful of how you enter those values. Now, when we start thinking about those 6 trig functions and we start thinking about how they are in our from our initial angle and all the way around to 360 degrees, they are ratios, as you know, and r is always positive, that we've already talked about. However, if I have my first quadrant, I would have every trig function to be positive. The reason being x and y are both positive, and of course r is positive. So all of the trig functions are positive in quadrant 1. When we get now to quadrant 2, we have to think about which is a negative value. Is it x or is it y? Since it is the x value that is negative, the function that is going to be positive there is sine, and of course its reciprocal. Getting down to the third quadrant, x and y are both negative. If I have a negative divided by a positive, obviously I'm going to have a negative. However, remember that the tangent and the cotangent are y over x or x over y. I have a negative divided by a negative. So in the third quadrant, the tangent and its reciprocal cotangent are positive. Lastly, in quadrant 4, again, I'm looking at the values of, in quadrant 4, my x values would be positive, my y values would be negative, my r is always positive. Therefore, my cosine and my reciprocal function of secant will be positive. Now, of course, we've got a little trick on how to remember this, and the way that we remember it is we say all students take, not a room here, calculus. So in other words, starting in quadrant A, or quadrant 1, and going right down quadrant 2, 3, 4. Quadrant 1, all 2 students, 3 take calculus. All students take calculus, and you can label that. And A means all trig functions are positive. S, the sine and its reciprocal, cosecant. T, tangent, cociprocal, cotangent. And lastly, in quadrant 4, C, cosine and its reciprocal function of secant are positive in those quadrants. So over here, when we want to determine the sign of the trig functions, for 28 degrees, all are positive. At 210 degrees, 210 degrees would end up in quadrant 3. Positive would be the tangent, cotangent. The balance, of course, sine, cosecant, cosine, and secant would be negative. When I look at the angle negative 68, negative angle, you've learned the other in 5-1, negative means I'm coming clockwise from the initial side, 68. So I would be in quadrant 4. In quadrant 4, the cosine and its reciprocal, the secant, are positive, and all the other 6 trig functions, the sine, the cosecant, the tangent, and the cotangent are all negative. Here we have a problem that says find all six trig functions given that the cotangent of theta is 4. Well, first off, I have to think about the cotangent of the angle being 4. The cotangent being 4, being positive, could be in quadrant 1 or it could be in quadrant 3. The next thing I have to then realize is that the sine of theta being less than or equal to 0, meaning it's going to be negative, would have to then be in quadrant 3. So this must be in quadrant 3. The cotangent of theta, being that it is 4, means my tangent of theta would have to be 1/4. Keeping in mind that the tangent is y over x, I then know that because it's really in quadrant 3, it's when y is -1 and x is -4. And I certainly can then find my radius. This will be -1, this will be -4, and I can certainly find my radius r by using the Pythagorean theorem just like we have done. So r is going to be equal to the square root of -1 squared plus -4 squared. And of course, r would be equal to the square root of 1 plus 16, which of course is the square root of 17. Now that I have that r is the square root of 17, well, I already have my cotangent given, and I have the tangent because it's the reciprocal function. Now I can find the sine of theta, the cosine of theta, and once I find those, I can simply give the reciprocal functions. So the sine of function of theta, of course, again, is y being -1 over r square root 17. Again, I must rationalize my denominator. So I will have negative square root 17 over 17. My cosine is x over r, or the side adjacent over the hypotenuse. So I have -4 over the square root of 17. Rationalizing my denominator and doing square root of 17 over square root of 17 will be -4 square root 17 all over 17. From there, I can get my reciprocal functions. The cosecant of theta is going to be, again, I'm going to go back to the original ratio because then I don't have to worry about that denominator of being a radical, and it would simply be this negative square root of 17 over 1, which of course is just negative square root 17, and the secant of theta would therefore be negative square root 17 over 4. Well, now that we've talked a lot about what those ratios are, we need to think about the range of each of the trig functions. The range of the trig functions, you have to first keep in mind that since r is the hypotenuse, r is going to be the longest side. Keeping in mind that anytime in a right triangle, x is less than r, y is less than r, if you write that y is less than or equal to r, and if you divide both sides by r, you find that y over r is less than or equal to 1. So y over r is the sine function. So the sine has got to be between -1 and +1. Similarly, x has to be less than or equal to r. When you divide that by r, you have that x over r is less than or equal to 1. That's my cosine function. So I know that the sine and cosine has a range of -1 to 1. When I then talk about the range of tangent and cotangent, keep in mind it's x over y over x over y. Well, that could be anything. So my range there is going to be -infinity to +infinity. The secant and the cosecant, and that's similar to what we talked about with the sine and the cosine, remembering that they are reciprocal functions. Because they're reciprocal functions, the cosecant and the secant would have ranges from -infinity to -1, and jump over that interval that the sine and cosine, and then start at 1 and go to +infinity. With that said, we can determine if these angles, if this is possible. For the cotangent to be -0.999, the cotangent -0.999, well, -0.999 is certainly within the range, so yes. Can the cosine of an angle be equal to -1.7? Well, I look at the cosine of an angle, and my range being from -1 to 1, -1.7 is not in that range, so no, it cannot. The cosecant of an angle. Cosecant, I look at my range, and again, 0 is not within that interval, so that angle, that is impossible as well. Okay, here's a problem that says I have an angle that lies in quadrant 3, and the tangent is equal to 8 over 5. Find the values of the other 5 trigonometric functions. So let's go ahead and draw a quick little picture here. I'm in quadrant 3, so I only drew quadrant 3. And I know that the tangent is equal to 8 over 5. And again, I have to know what that is. And of course, that is y over x. So my x has to be -5, and my y has to be -8. They're both negative because they're both in the third quadrant, but because a negative divided by a negative is a positive, and that's why the tangent is in fact positive. So let's grab a line here. My point again there is -5, -8. Let's grab another line. I have my right angle. Again, my x value is -5. My y value is -8. And of course, to find my trig functions, I do have to find my hypotenuse. So r is equal to the square root of -8 squared plus -5 squared, which of course is the square root of 64 plus 25. R would then equal the square root of 89. So the square root of 89. And I'm just thinking if that could be reduced, I don't see anything off the top of my head. I don't see any perfect squares in there at all. Even 49, 36. I don't see anything in there that can be reduced. Now that we have our radius of r being the square root of 89, our hypotenuse r or r square root of 89, we can then find our trig functions. So here we go. Sine of theta, again, is opposite, and theta is always here. Opposite over the hypotenuse, or y over x. So it's negative 8 over the square root of 89. Again, I got to rationalize my denominator. Multiply by the square root of 89 over square root of 89 to get negative 8 square root 89 over 89. Its reciprocal function, the cosecant of theta. Again, I'm going to go back to where I first found my ratio, and that's going to be the negative square root 89 over 8. Cosine of theta, again, is x over r, or adjacent over hypotenuse, which would be negative 5 over the square root of 89. Rationalizing my denominator, square root 89 over square root 89 would be negative 5 square root 89 over 89. The reciprocal function then secant of theta, again, I'm going to go back to that first ratio. It's the simplest, and I'll have negative square root 89 over 5. I already had the tangent. The tangent of theta was 8 over 5, so therefore the cotangent of theta, of course, is its reciprocal of 5 over 8. The Pythagorean identities. The Pythagorean identities here on the screen, sine squared plus the cosine of squared is equal to 1. That should look very familiar to you. Pythagorean, x squared plus y squared is equal to 1. We also have the identity that the tangent squared plus 1 is equal to the secant squared. 1 plus the cotangent squared is equal to the cosecant squared. This says to find the cosine of theta given, and the tangent of theta, given that the sine of theta is equal to the negative square root 2 divided by 3. Well, we can use these Pythagorean identities to be able to solve this. So we're going to use the very first one that says sine squared plus cosine squared is going to equal 1. And the sine of theta is equal to negative square root 2 over 3. So negative square root 2 over 3. I'm going to square it. That must equal the cosine squared theta must equal 1. Of course, once I square that, I have 2/9, and a negative times a negative, of course, is a positive, plus the cosine squared theta is equal to 1. I'm going to do my algebra, and I'm going to subtract 2/9 from both sides, finding that the cosine squared theta is in fact equal to, of course, it's going to be 7/9. Remember that this is the same as 9 over 9, so I can subtract. To find the cosine of theta, I'm going to take the square root. It would be the positive or negative square root of 7/9, which of course would be the positive negative square root of 7, all divided by 9, or square root of 9, which is 3. Now I have to remember, when I go back up here, that the sign is negative, because the sign is negative, could actually be in many different quadrants. However, I forgot to type in, and I just had to stop and look, and it says in this problem that the cosine of theta is greater than 0. So that's an important component considering I need to know which route to take. Because the cosine, sorry about leaving that off, cosine of theta has to be greater than 0. That means I'm going to reject the negative root, and my cosine then of theta would in fact be the positive square root 7 over 3. Now that I have the cosine of theta and I was given the sine of theta, I can find the tangent of theta, because the tangent of theta is equal to the sine of theta divided by the cosine of theta. The sine of theta that was given to me was negative square root 2 over 3. I found the cosine, which is the square root of negative 7 over 3. Well, I really have division. I have a divide by a fraction divided by a fraction, which is really negative 2 square root 3. Um, I'm going to multiply by the reciprocal, 3 over the square root of 7. Those cancel. I get negative square root 2 over square root 7. You know I can't leave it that way. So now from negative square root 2 over the square root of 7, I'm going to rationalize my denominator. So I'll end up with negative square root 14 all over 7. Our next example here asks you to find the sine of theta and the cosine of theta given that the tangent of theta is equal to negative 7/24 and theta is in quadrant 2. So I know that I have theta in quadrant 2. In quadrant 2, we know that the sine is positive, the cosine is negative. The tangent, as it gives me, is found to be negative. So the cotangent of theta equaling negative 7 over 24. Remember, the cotangent is the reciprocal function of the tangent, which would be negative 24 over 7. And I know tangent, of course, is y over x. So my x is 7, my y is 24, and of course I still need to find r. Finding r, I would have r is equal to the square root of 24 squared plus 7 squared. And I believe once you're completely finished through here, r is going to end up being 25. It's just one of those triangles that you learn to remember, 7, 24, 25. Now that I have the r value, the radius equaling to 25, I'm ready to find my sine, theta, and the cosine theta. Because sine, I know, is y over r, side opposite over the hypotenuse, so it would be 24 over 25. And my cosine is x over r, which of course is 7 over 25. Now keep in mind, I have to remember what's positive and negative. Here, my x is the negative value, and it's going to have a negative on my cosine. Remember, all students take calculus. S being sine and its reciprocal function are the only two that are positive in quadrant 2. So another check. That is the end of section 5.2. I know it's lengthy. Get in there and really try to work through a lot of these problems. And I'll be doing another video for section 5.3.